Hello all. So I want to talk about physiology again, and basically how physiology can help inform our understanding of complex PTSD and the treatment therein, but also how to restabilize the hypothalamic pituitary adrenal axis. Thank you for tuning in. So Stephen Porges' theory and company, I should say, the Polyvagal Theory helps us understand, gives us a roadmap really for working with restabilization of the hypothalamic pituitary adrenal axis. If you're not familiar, I'll give you the brief rundown. Polyvagal theory basically has taken our understanding of the autonomic nervous system and turned it on its side. Basically, rather than this understanding of parasympathetic versus sympathetic, where parasympathetic is more linked to the vagus nerve in particular, and sympathetic is linked to fight or flight, the polyvagal theory adds in a third autonomic space and turns it on its side. So instead of one versus the other, it's states that one drops into based on the progression or needs. Or I should say regression even, because the oldest form is at the bottom and then fight or flight. So the oldest would be the dorsal part of the vagus nerve. This is unmyelinated and it's associated with freeze. Fight or flight in the middle, associated with the mobilization of a response to get away from the predator or fight the predator. And then the third, at the top, the most recently developed, would be the parasympathetic that we think of, although both are vagus. The ventral part of the vagus, where we have the rest and digest, but also the mobilization of social type cues or social scenarios. Rest and digest and sip wine. So in those three states, in understanding his theory, it's not merely that you have this physiological response, but rather because of the way the autonomic nervous system works, there are behaviors and certain neurons that especially affect behaviors that are paired to each state. Why is this useful for understanding trauma and the HPA axis, you say? Well, let me help out. So when you're in fight or flight and it doesn't work out, the lioness is caught up to the gazelle, and now you're in the mouth of the lioness. That typically triggers a freeze response. From an evolutionary standpoint, this is useful because all the things that kind of get amped up in the middle, in the sympathetic response to mobilize you to run away or fight, get dampened down again. And so you see, right, you need blood to the skeletal muscles to run. But once you're in the period of time where the lioness is going to consume you for dinner, it would be helpful to have less blood flow because that's going to be associated with pain. So all the things that happen, basically there's a reversal almost where things shut down, slow down. There's a numbing, a dissociative type scenario that happens. So one, less pain on dying. Two, potentially you appear dead. Why is that useful? Well, lioness may go call the cubs for dinner, and in so doing, you get a chance to escape. So dropping into the free space is adaptive and useful, and this is probably why we still have this capacity. And according to polyvagal theory. The other piece would be, you see if when this is a hierarchical picture, you start from 1, go to the middle, and then drop to 2. The route, though, for coming back up is you have to pass through fight or flight. Clinically speaking, this is useful knowledge. I wish I would have known this a few years ago. Because it's often the case when you're working with people who have experienced massive amounts of trauma that, they're in a freeze state, they're in a dissociated state. You want to bring them out of that. You bring them out of that, or do something that helps get them out of that, and they're back in a fight or flight, which feels acutely quite stressful. So knowing you're going to pass through that in order to get to parasympathetic and that rest and digest, calmed nervous system, that's useful knowledge to prep someone for, as we treat you, you're going to go through that. Just understand that. Knowing is half the battle. But secondly, another thing that this informs us about would be some of the paired behaviors that Stephen Porges and company has sorted out because of the way the neurons are connected when it comes to the autonomic nervous system, would be understanding those pieces. So an example of this would be, there's a tendency, I've observed this, I've experienced this myself, when dropping into fight or flight or freeze, especially if it's a chronic sort of destabilization of the HPA axis, then social engagement behaviors kind of go out the window. I always thought, it's just me. You pull back. You don't necessarily want to engage. If you have experienced trauma in the context of relationships, which is pretty common for most people these days, the narcissistic abuse, then what happens is, you would think, it's because of the pattern I've figured out. Abuse by a narcissist means humans are dangerous, right? Therefore, do not engage. In all actuality, that's probably one piece of it, but the other piece is that it's physiologically paired to the fact that if you're in fight or flight or freeze, those states shut down things that increase social engagement. What do I mean by this? Well, one of the innervations, meaning neurons, 2 of them, in fact, they're paired, to the auditory centers. Basically what happens is the acuity for certain sounds increases, certain kinds of sounds, when you are in a fight or flight. You become hyper acute to really high pitches and low pitches. Why? Because that's the range you need to be most in tune to in terms of danger. So high pitch sounds are often dangerous. Low pitch sounds could be the growling bear. The range where the human voice resides, not so much. So in all actuality, you're deaf. It's an overstatement. But the volume gets turned down in terms of the taking in the information in the range of human voice, because we don't need that. We don't need to be socially engaged while we're running from the bear. We need to hear loud, high, and low. But not so much in the middle. Well, if you're in a chronic fight or flight state, you're going to have that same experience, except let's say it's now as the result of a traumatic relationship. Well, it's going to be harder to engage humans that talk in this range. You're going to be outside that, really in tune to those noises that might, be dangerous. So physiologically, that helps us understand part of the behavior patterns that emerge. And again, keep in mind, this is involuntary. So it's not like well, I'm just trying to hear the really bad sounds out there. No, your body just automatically does this. Secondly, the facial nerves are not as innervated. I don't mean that the nerves like move away. What I mean is that we divert and mobilize the parts that we need because we got to run from the bear. Contrary to what Instagram or your social media feed may have you believe, what you look like while running from said bear doesn't matter. So, we don't worry about facial expression from a survival standpoint. Therefore, what happens is in a fight or flight space, you get a flat affect. Someone kind of shuts down because everything else is mobilized, not so much the facial muscles. The acuity to the pupils, actually, the range that our sight is most in tune actually is further out. So again, people being up close, you're not as in tune visually to that. Because you get in fight or flight, you get dilation of the pupils so you can see at greater distance so you can run. Not so good socially. All of these pieces, and there are more, these are just a few examples, help us understand then when someone is chronically in a state of fight or flight or freeze or ping-ponging between the two, then a lot of these behaviors may not necessarily be on the level of choice. We can do things that help influence moving somebody out of fight or flight back into parasympathetic based on what we understand physiologically speaking. Another thing to understand would be, so with freeze in particular, this is the dorsal part of the vagus, so the oldest part of the vagus. And while this whole system is pretty much not under voluntary control, there is one crossover bit. So the part of you that you can control voluntarily would be respiration. So yes, it's also controlled involuntarily. There's a part of the brainstem is where we control respiration. However, there is voluntary override when it comes to breathing. This is probably why a lot of our spiritual traditions and some of the things that crop up, in terms of chanting or like even breathing in certain ways, like you would have with meditation, where in particular where the exhalation phase of respiration is increased, that actually works to influence the part of the vagus nerve, the dorsal vagus, that's below the diaphragm that has the most to do with freeze. And so we do have, as much as I've told you, this is, involuntary, the autonomic response. You don't really choose, I'm going to go into fight or flight. Oh, and then I'm going to go into freeze. You basically just ping around between them. And like I said, you can get stuck. And that's what we see in trauma all the time, right? The complex trauma, somebody's stuck in this loop of either hanging out in freeze or hanging out in fight or flight or pinging back and forth between the two. And that, knowing that we can influence it with the breath, makes complete sense. Also knowing that we have these overlapping pieces with behavior and, between parasympathetic and sympathetic, we can influence shifting back into parasympathetic out of sympathetic with certain kinds of things. It might be the case that this is how NLP works, right? If you're familiar with NeuroLinguistic Programming, think I'm getting that right. I'm not an expert, but it's been my observation that, you know, it has a lot to do with regulating somebody's facial expressions and mannerisms. And it might be that is actually the underlying physiological thing that's going on, right? You're helping shift somebody out of a sympathetic space by tuning into the facial neurons, the facial muscles, and in so doing, helping them leave the sympathetic space. Interesting, huh? Like I said, I'm no expert on NLP, but that just occurred to me that, I wonder if that's how it works. So keep that in mind, but also keep in mind that when we go to move somebody out of freeze, that they're going to move from freeze into fight or flight because of the hierarchy of the system. So that knowing's half the battle. Gotta go through that space to get to parasympathetic, and sometimes warning somebody that might be the case may help you get them back there, because you can't access parasympathetic directly from freeze, from the dorsal vagus, according to the Polyvagal Theory, which makes sense. You can influence it, but you will shift somebody through fight or flight first. So that's really useful to know. Like I said, I wish I would have found this sooner. Thanks for tuning in. That's about all I'm going to say. Let me know what you think. Check it out. If you haven't yet looked at Stephen Porges' Polyvagal Theory, then I highly recommend you do so, because it can really help inform our understanding of how to restabilize the HPA axis. And the one last final thought I want to add would be social engagement at the top with parasympathetic is this picture of how to get to that space, we do have to re-engage with other people. We're designed to be connected to other people, and so healing doesn't happen in isolation. So it's kind of an interesting picture there. We'll talk about this more, but thanks for tuning in. Adios.